Welcome. Today we're going to be talking about corresponding parts of congruent triangles being congruent. We're going to be using congruent triangles, our previous topic. Once we know that they are congruent, we'll be using that fact to show that the other parts not named in the triangle are used to find that they're congruent are also congruent as well. We have two triangles in this picture that are side, congruent. All three of their sides are congruent to each other. The congruent statement that we could write for these two triangles would be the following. Triangle ABC would be congruent to triangle. The A would match to D, so D would have to be first. Corner B or angle B would match to E, so that E would be second. And finally, angle C would match angle F. But those three sides we have named here are not the only things that are congruent about these two triangles. There are 6 total things in both these triangles that we know are going to be congruent. I've listed on the right-hand side all of the angles that would match each other if these two triangles are the same, as well as all of the segments that make up the sides of our triangles that would also match each other. For instance, AB would match to DE. We have BC matching to EF, and CA matching to FD. The order of your segments doesn't matter quite as much as the order in your triangle statement, but it's still fairly important and good practice. And like I mentioned already, we have angles that would match up. A matches to D, B matches to E, C matches to F. When we were doing just congruent triangles, we only needed 3 out of these 6 in a specific order in order to show that the two triangles are congruent. Once we've used those 3, we have the other 3 we can also say are congruent from there if we've already said that the triangles are exactly the same. Important when we think about writing out proofs, we've already done lots of proofs of writing from our given information through using vocabulary, finally getting to a congruent triangle statement at the end. And now we're going to add really only one extra step onto that process so that we can say an extra angle or an extra side is going to be congruent. And when we're thinking about this, we're going to be using these sorts of things to prove other geometric theorems in a following lesson. Things like about isosceles triangles or things about perpendicular bisectors, et cetera, et cetera. We will also be applying these to some real-world situations and using some algebra with them as well, all using CPCTC, which is the abbreviation for corresponding parts of congruent triangles are congruent. The acronym is a little hard to remember, so I recommend not necessarily using the acronym very often until you're very familiar with what it stands for. We have an example here of using our corresponding parts idea. So in this triangle, we want to prove that side AB, and we're missing an A up here at the top, so we can just write in an A as our missing point for this top point of the triangle. But otherwise, and these question marks, that's just the congruent symbol. It wasn't available when this PowerPoint was first made. So it's really just a congruent symbol if that was confusing. Basically, we are given that AC and DF are congruent to each other. They each have one little tick mark. We also know that angle C and angle F are congruent by given that in the problem. And so we can kind of mark those as congruent angles with one little angle marker. And finally, we are told that CB and FE are congruent to each other because they both have 2 little side markers on them. Now, from just that, we can see that these 2 triangles have side, angle, side congruence. Same thing for the second triangle, side, angle, side congruence. And we are able to figure out that that is the type of congruence that we need. And you can see that I have circled it right there. Now that we've shown that the 2 triangles are exactly the same, Well, that means all the other matching parts would also be the same. That would mean that since AB would match and line up with DE, if we kind of translated that top triangle downwards, we can say that those two sides are congruent. You could even extend this and instead say that angle B is congruent to angle E because of those being corresponding parts as well. Most proofs will not be as easy as being given all three things and then getting your triangle congruence. You'll have to use vocab like we've been doing lately, but this is the general idea of what is happening. We have a proof here that we are going to be working through. So I want you to take some time to pause the video now to see if you can fill in or what you would say for each of these statements 1 through 5, and then the reasons that would go through each of them. And then we'll look at what it would be filled in just a moment. We've written down our two given statements provided in the problem, but we were also shown that we can mark this bottom side on these two triangles as congruent to each other. So we're going to add that as a third given in this case. So we're going to say that WX, that line segment on the left, would be the same thing as XW on the right there. And so we have those as congruent statements, and we'll just write that as given as well. And then we want to think about what the triangle congruence would be, and then we're going to go to corresponding parts. So take a second, what would be the corresponding, the congruent triangle type? If we look closely at our triangle, we have an angle, a side, and an angle in both of these triangles. So we can say for certain that we have angle, side, angle as our type of congruence. And then we just want to make sure we're labeling our triangle with the correct labeling. Now that we've established that these two triangles are angle, side, angle congruent to each other, well, now that we've established that, we can write down what we're going to prove at the very bottom here and write down that ZW is going to be congruent to YX, and that is based on that acronym corresponding parts of congruent triangles are congruent. And that kind of wraps up this particular proof. As you can see that from the first 4 steps, just like what we've done in the past with triangle congruence proofs, we were really only adding one extra step using this corresponding parts of congruent triangles idea. We are continuing on with corresponding parts of congruent triangles right now. And we're going to be looking at some example problems where we are applying our knowledge that we have learned. So we're going to work on about 6 different problems here. And so we will be starting to look through them starting now. So in our first example here, we are looking at triangle HEY and then triangle MAN. And we can see that they are congruent because we have 2 angles and a side in both of them. So we are going to say they're congruent by angle, angle, side. We know that we have, for instance, HE are congruent to MA. Those 2 segments, Y and N, are congruent. We want to think about what other things we need that could be congruent. So there's going to be 2 more sides and 1 more angle. And you can list them in any order you like. But for instance, we could write that angle H is going to be congruent to the other unlabeled one, which would be angle M. Then we could say that HY, that segment right there, HY, is going to be congruent to, if you kind of think about what it would be going from 2 to what we had was nothing before. So 2 to what was nothing before would be this over here, m to n. So mn would be congruent to hy. And then finally, our only missing side would be, on this case, on the left triangle, we have ey. And on the triangle on the right, we would have going from 1 to 2. From 1 to 2 over here would be a to n. And so we have labeled all of these different triangle parts that were not part of our original congruence. In number 2, we have triangle cat is congruent to the other triangle in our diagram, but we just need to make sure we label it correctly and figure out what kind of congruence it's going to have. So for instance, triangle CAT will be congruent to triangle RAP. And that is going to be angle, side, angle congruence. My angle, side, angle congruence. And you could probably just leave it as angle, side, angle if you wanted to. That wouldn't make a giant difference. And so we're going to kind of do the same thing we were doing in number 1. And we're going to make sure we notice here by CPCTC. Remember, the acronym can be confusing even to remember what letters to use. So it might be better to write it as like corresponding parts of congruent triangles. That's sort of a different kind of abbreviation that might be a little bit easier to write and also to remember. So let's label the rest of our triangle with the parts that we would know after finding out that the two were congruent. So the easy one we can pick is CT is congruent to RP. And we have TA is congruent to PA. And that takes care of both of the segments that we've been missing, other than the one we already had. And then we just need to write down our angles that weren't mentioned. And that would just be one of these angles, angle T, and then angle P would also be congruent by our corresponding parts of congruent triangles, our congruent idea. Moving on to number 3 at the bottom here, we are going to actually do a proof here, filling in the blanks using what we already know about congruent triangles. So first and foremost, as with all proofs, we got to start with writing out our givens. So AC and A is congruent to AR up right here is a congruent segment. So that is a given. And also angle 1 is congruent to angle 2. And that is also a given right here. But we want to make sure, remember, to mark that on our diagram as usual. So we're saying that AR is congruent to AC. And we've said angle 1 and angle 2 are congruent to each other. So now angle CAL, which would be this angle right here. And then we have angle RAS, would be this angle. So if we think back to our vocabulary that we've talked about lately, well, that means, well, those are congruent because those are vertical angles. So definitely congruent there. And then lastly, for the congruent triangle part, well, that means that we have an angle, and a side for both of these two triangles. So these two triangles are congruent by angle, side congruence, to abbreviate that a little bit. So now, because we've said that these two triangles are congruent first, now we can say after that, the 3 and 4 are going to be congruent as well to each other. So those would each get 3 little angle marks at C, or at angle 3 and angle 4. Those are, and I'm going to use my new abbreviation, corresponding parts of congruent triangles are congruent. Or if you wanted to write it as CPCTC, that would be okay too. Moving on to the back of the page, we have some more proofs that we're going to be walking through here. So let's go through those now. And so to start off with, we have in number 4, we have what looks like a sort of a parallelogram type shape. And we have NLM. NLM is this angle up here, and LNO is this angle right here. We know those are given. And so we'll write given as our reason right there. And then we have number 2, another given. So we're going to write down this given right here. And so that means we can write down angle OLN is congruent to MNL. And that is also given. And we want to make sure to label that OLN, this angle right here, and MNL, this angle right here. So our two double angle markers, those are congruent because those are also given. Our line segment LN in the middle here is as a side on both of the 2 triangles in this diagram. So we can say for sure that that is congruent to itself. And we can write that as LN is congruent to LN by that reflexive property. And so we have 3 things in both of these triangles. We have angle, side, angle congruence. And we want to make sure we're labeling it correctly. So L to M to N would be this top triangle. So we need basically we're going to go from 1 angle marker to 0 to 2. And that's how I like to do it. We're going from 1 to 0 to 2. That would mean that we have N, 1 to 0, O to 2, L. Triangle NOL. Now, generally for your ending proofs, what you're trying to prove is going to go on the bottom line. And then we know that M is congruent to O using 3 angle markers here, that we have CPCTC is the reason we know that. Corresponding parts of congruent triangles are congruent. Now let's move on to number 5. So we're going to first mark down in our diagram what's going to be congruent to what. So AC is going to be congruent to BC. And we have that written, so let's write it on our list of things here. And then we have that as given. And we also have that CX would be the reflexive property. So we could say that CX is congruent to CX. And what I forgot to do here in number 1, we're just going to combine both those givens into one line just to be economical. So we can say also that AX is congruent to BX. And that would mean that these bottom segments on both these triangles are congruent. And since we have 3 sides in both of these, well, that would mean that we have side, side, side congruence. And to match our triangles together, AXC would, this one's a little bit easier, it would just be BXC for our second triangle. And like before, we know we're going to be doing corresponding parts of congruent triangles to figure out that 1 and 2 are equal to each other. Angle 1 and angle 2 are definitely congruent. Those angles would match each other on these 2 triangles. So those are corresponding parts of congruent triangles that are in fact congruent. And finally, we are on proof number 6. And we can try to adjust this a little bit. So for our last proof, we are given that angle 1 and 2 are the same. So we can go ahead and mark that on our diagram. Angle 1 and angle 2 are the same. We also know that angle 3 and angle 4 are going to be equal. So we can give those two angle markers. Angle 3 and angle 4 get 2 angle markers. And we're just going to write them both on the same line for our given statements, that these two pairs are going to be congruent to each other, and they are given at the top. So xz and xz, just like before, those are reflexive property. And we can write that as our reason for this one. We have shown that we have angle-side angle congruence in both of these two triangles by showing that with our diagram up here. So x, w, z, going from 2 to 0 to 1. So we'd have z, y, x for our second triangle. Now that we've proven that all of those parts of this triangle are congruent by angle side angle, we would then know from there that x, y, our side at the bottom, and z, w, our side up at the top, would also be congruent, because those would match each other, those would correspond to each other, and we know that they would match and be equal because they are corresponding parts of congruent triangles. And that finishes proof number 6 and this practice worksheet.